Okay, in this lecture, I'm just going to go over how to do the worksheets for this week. I'm going to do the first worksheet and then we'll do the second worksheet in the next video. So I'm going to share my screen here, share screen one, and let's take a look at this. So this worksheet right here is going through measures of location is really what we're doing, and also the values that coincide with that. And so let's just take a look at this. Going down, you've got location. When the data is put in logical order, every single piece of information has a location. Central location is, it's centrally located. You've got the weighted mean, so on and so forth. And then, put an example, a real world example right down here. And then choose the best measure of central tendency given the situation. So come down here and say, okay, we've got this, what should we use? We've got this, what should we use? We've got this, what should we use? The big thing is, and I'll tell you right now, mean, median, and mode properties. People often ask, when should I use the median? When should I use the mode? You use the median, when should I use the median? When should I use the mean? You use the median when you've got extreme values. Okay, and you're like, oh, wow, there's a huge outlier. Use the median. Other than that, the mean is almost always the best use. And then the mode is really only there when you're like, hey, I really need to know what happens the most often. So the only time that you use the median is when you got like a bunch of extreme outliers, and then you use the mean pretty much almost all the time. And then you use the mode really only when you want to know what happens most often. So that kind of helps you with that down there. All right, so for the data set below, find the arithmetic mean, median, and mode. First thing, step one, put them in order, okay? 3, 15, oh, no, hold on, 3, let's see, 7, 9, so we got this, 3, 7, 9, then we got 10, then we got, let's see here, 15, then we got 3, 7, 9, 15, 17, then we got 19, then we got 23, 23, and 27. So first step, done. Mean. What is the mean? Great question. So this is what I would suggest for you. Anytime that you want to find the mean on the quiz, exams, whatever, just go right here and then do, hey, lickety split. Well, I got to turn off TikTok, sorry. That's from the previous lecture. Whoops. You guys can thank thank Shaq for that. Wonderful. Okay, file, new. Okay, here we go. So anytime that you do this, you just copy and paste it into here and then do equals mean, or sorry, equals average. And then highlight it, and bada bing, bada boom, 15.3. So we're good there. So 15.3. You can also add these up by hand and divide them by, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So add them all up together and then divide them by 10. So if you were to do equals sum, oops, then you do equals 153 divided by 10. It would give you the exact same thing. Okay, so median. So the median is going to be the middle value. So you've got 5, and then you've got 5. So the median is going to be halfway in between these two. So it's going to be 16. So you take the average of the 5th value and the 6th value together. Okay, and then the mode is 23 because that's the one that occurs most often. So which one is the best to use? Should I use the mean, the median, and the mode? And I'm going to say mean because there are no extreme outliers. Okay. Because I'm not asking, what happens the most often. All that I'm asking is give me the best measure of central tendency. Okay. Location of first quartile. No, this is really important. There's a difference with location and value. Location versus value. Location, There's that fun little formula where you've got, the funny thing is this is the only formula that's not on the formula sheet. And it's not even up here. Um, but it is in my lectures. So the location of the first quartile, you are going to do 0.25, or you can do 1 divided by 4. That's the first quartile, or it's the exact same thing as 25 divided by 100. Okay. And then the first quartile, it is going to be that multiplied by, oops, sorry, multiplied by the number of observations plus 1. So it's multiplied by n plus 1. So that right there is going to be 10 plus 1. So you have 25 over 100, or 1 over 4, multiplied by 10 plus 1. So you've got equals 0.25 multiplied by 11. Okay, so 10 plus 1, which is going to be 2.75. And so the location of the first quartile is going to be 2.75. Okay. And then the third quartile, instead of 25, you can do 75, or you can do 3 over 4. It's the exact same thing, because 3/4 is the exact same thing as 75 over 100. So what we're going to do is we're going to come right over here, and we're going to do 0.75, which is the same as 3/4 multiplied by 11. So it's 8.25. So third quartile is 8.25. Then the value of the first quartile. What is the value of the first quartile? The value of the first quartile, or the delineating point between the first and the second quartile. So you go to 2.75. So you've got 1, 2, and then 3. So what you do right here, you've got it's somewhere in between here, but where in between here is it? It's 3/4 of the way between there. So you've got, what you do is you take 9 minus 7, so that's going to be 2. So it's going to be equals 2 multiplied by 0.75. And the reason you multiply it by 0.75 is because that's the remainder. So you take that remainder right there, so 0.75 multiplied by the difference between the 2 and the 3. Okay, so multiplied by the difference between the 2 and the 3. So 2 multiplied by 0.75, so 1.5, and then you add that to the 7. So the value of the first quartile is going to be 8.5. Sorry, 8.5, because you take that 0.75 multiplied by the difference between the second and the third value, and you add that to the value of the second, um, the second value there. So coming to the third quartile, what is the value of the third quartile? So it's going to be the value is whatever is in position 8.25. So we go to position 8.25, 1, 2, 3, 4, 5, 6, 7, 8. When I say position, position is the same as location. Okay, that's how it's positioned in the data set, or where it's located in the data set. So so you've got 8.25. Now this is weird. 8.25. If the 8th value and the 9th value are the same, what should I do? If I need to take that 0.25, what I'm supposed to do is I'm supposed to do equals 0.25 multiplied by the difference between the 8th and the 9th value. So multiplied by the difference between the 8th and the 9th value, and add it to the 8th value. Well, if the difference between the 8th and the 9th value is 0, okay, so you take that 0.25, multiplied it by 0, which gives you 0, and then you take that equals 0 plus the 8th value, which is 23. And so right there, you've got it's actually 23. So if you have something like 8.25, and both the 8th and the 9th value are 8.25, or are the exact same thing, then just put 23. So coming down here, what you have here, the max, I kind of have this weird. Whoops. Don't you hate it when that happens? What I really meant to do is do this. Sorry about that, guys. Sometimes you just copy and paste, copy and paste, copy and paste, and you don't even realize what you're doing. So minimum, so we've got the min. So the minimum is going to be 3. Quartile 1 is going to be 8.5. Median is going to be 16. Quartile 3 is going to be 23. And max is going to be 27. And then you go through all of these, which I'm really frustrated with myself right now with messing all these up. That's just so frustrating. And so I'm going to have to go, I don't even know how I ended up, like, why in the world did I think that that's what I should be doing? This is the first semester that I've actually put this together in this fashion. I was trying to give you guys all a visual. There we go. I mean, I suppose if you did it all, you guys know what you're doing. It's just, it aesthetically looks better going in the other direction. And it really should be going in the other direction. Okay, so you keep doing that all the way down. And then when you come down to the very bottom, it says, okay, I want you to find the mean and compare the mean to the median and determine if it's skewed. Okay, so taking the mean, so let's look at the mean right here. Look at the mean compared to the median. If the mean is less than the median, then it's negatively skewed. So you can come right down here and you can put negatively skewed. So because the mean is less than the median, and you could put this if you wanted to, mean 15.3. Because the mean is less than the median, it is negatively skewed. And then just go all the way down and you're just comparing the mean to the median. And that's all that we're doing really regarding skewness in this unit. So yeah, hopefully that helps with 1.31 and 1.32. And then I'm going to go over the one for the second half of the week as well in the next lecture.